Many compelling programming experiences like programming by demonstration are difficult to implement on top of existing programming systems. Denicek is a new computational substrate that makes it easy to implement support for a broad range of those interactions. In local-first collaborative editing, one user adds content to a document while another user transforms its structure. We want those edits to be merged automatically. In programming by demonstration, the user edits one row of a data table. We want the system to generalize those edits and apply them to the remaining rows. In an environment that supports incremental recomputation, we want the system to recognize what results have been affected by an edit and then invalidate and recompute only those. Finally, we want programming systems to support schema change control, where references in code are automatically updated to match structural edits to the document. The Denicek Computational Substrate makes it easy to support those programming experiences. Denicek is based on a simple idea. It keeps an edit history and obtains the current state of the document by applying the edits. The key operation in Denicek is merging of edit histories. Given two edit histories that share a parent, Denicek can merge those into a single linear history. In many cases, edits that affect a shared part of the document can be reconciled to reflect the new history. Denicek also detects conflicting edits and can mark those as invalid. This key operation is at the core of our implementation of many programming experiences. It's used when merging edits during collaborative editing, replaying edits recorded during programming by demonstration, invalidating edits produced by formula evaluation, and keeping references in document in sync with its structure. We co-designed Denicek with a formative prototype programming system called Denicek. To evaluate our design, we then use it to build an innovative notebook system for data science called Denicek. During the design phase, we use a series of formative examples. In the first one, Evelyn builds a counter app. She first constructs the HTML document for a counter with an initial value 0. She then wraps the count in a formula that increments the value by 1. Next, she selects those edits in the history, saves them in the document, and attaches them as an event handler for the button. Now she has a working counter. In the second formative example, Juliana and Alfred are organizing a conference. Juliana first adds a new speaker to the document. She then implements a budget calculation that counts the number of speakers in the list and multiplies the count by travel costs per speaker. Meanwhile, Alfred refactors the list into a table. He adds a table header. Then he splits the original single list item into a name and an email. To do this, he makes a copy of the value and extracts a different part of the value in each of the two copies. When Juliana merges the edits from Alfred, she notices that the speaker count now points to the rows of the table and the computation works as before. To evaluate our design, we use Denicek to build a collaborative notebook system for data science that supports interactive data cleaning. In our example, Juliana constructs code to load data on air traffic accidents from Eurostat. She notices that one column contains all the metadata and some values are not numerical. She opens the data in an interactive table editor. She renames and splits the column with the metadata. She then removes unneeded columns and notices a duplication in the dataset. She filters the rows and also removes rows representing aggregate values. Then she corrects a non-numerical value and applies the edit to the entire table. After checking the data, she turns the transformation into code and uses sum to count the total number of deaths. When building a visualization, she notices a poorly named variable and renames it. The edit automatically updates the variable reference. Meanwhile, Alfred edits the original document to look at the file recording injuries rather than deaths. When he merges edits from Juliana, there are no conflicts. The old results are invalidated and he immediately gets the new chart. To summarize, Denicek is a computational substrate built around documents and edit histories that makes it easy to implement compelling programming experiences. We present the design and evaluation of Denicek using two distinct programming systems.